Hi, my name is Pranuj Jain, and in this video, I'll be presenting our work, which was done along with my co-authors, Dr. Rostov Arzan and Dr. Adam J. Lee at the University of Pittsburgh. The focus of this work was the design and evaluation of a contextual auto-response messaging agent. Let's start with the situation. Suppose Laila is in a meeting when she receives a text message from Alice. At this point, she can either respond to the message or ignore it. Let's say she decides to respond to the message. This results in her getting distracted from the meeting, and the person she was meeting with will also not be happy with her looking at her phone during the meeting. Now let's consider the other possibility where she chooses to ignore the message. Here, Alice is not too happy about not getting a fast response, and Laila might later need to apologize and explain the reason for the delay. But what if Laila's phone can detect that she's busy and auto-reply on her behalf? In this case, knowing that an auto-response has been sent, she can continue to focus on the meeting, while Alice is also now aware that Laila is engaged in some other task. The situation I described earlier points to the issue of situational awareness in messaging. In face-to-face conversations, people can visually observe each other's environments. And even for phone calls, one can observe background noise to make inferences about the other person's state. With mobile messaging, these cues are often missing. To compensate, messaging applications use awareness tools such as online-offline status, last seen time, read receipts, and more recently, iOS 15's focus mode. Although prior work has pointed out that these tools are actually poor indicators of availability. Not only that, these tools have also been shown to raise privacy concerns, such as uninformed tracking, where people can constantly check their contact status at any time. Further, there are implications such as negative emotions when it is inferred that a person is available by showing them as online, or if red receipts are shown, but the response is delayed. With that in mind, our main goal with the design of this agent was to improve situational awareness and tackle shortcomings from prior work. Our focus with this design was to create a completely automated agent without requiring human intervention. We wanted to enable mutual awareness in the design, and instead of a simple status, we wanted the agent to provide context when informing unavailability, as typically that is how people explain or communicate unavailability. As the name implies, an auto-response is automatically sent upon detection of a new messaging session. As shown in this example, additional context is shared as part of the auto-response. And finally, since the auto-response is sent as part of the same thread of conversation, mutual awareness of the shared status is also maintained. So how did we design and develop this system? Our system comprised of two main parts. The Android application collects sensor data and messaging session information, which is then sent to the remote application server. This server hosts the personalized user model, which is then used to predict a user's state and identify important information related to that state. In the interest of time, I will not be able to go into the details of this design and various components. I encourage viewers to refer to the paper for the overall design and our prior work in user modeling to understand how these models were trained. And I also encourage readers to look into our prior work on context sharing to understand how we identified and evaluated the different auto-response types, which are listed on this slide. Next, I'm going to briefly go over the different response types that the agent generated. The slide also lists an example of each. The no context or simple auto-response did not share any additional context. Single feature auto-responses used a single feature value based on the top features in the model. User and device ensemble auto-responses combined user state and device state information to form a single auto-response. Weighted top feature ensemble auto-responses combined responses from multiple top features to form a single auto-response. And finally, clustered ensemble auto-responses included features from 3 dimensions of locality, time, and task information to form a single auto-response. To understand the perceptions related to this agent and the information it shares, we did a user study with 12 participants who used the agent for 2 weeks. In the first week, the agent collected data through a smartphone application, which it then used to train personalized attentiveness models. In the second week, the agent started sending auto-responses to the participants' contacts. We saw a significant number of auto-responses being sent during the user study. In particular, 310 auto-responses were sent, ranging from 6 to 61, with the median being 23. The most common auto-response type was the phone usage, which makes sense since phone usage was one of the top features from prior work in attentiveness modeling. Next, I'm going to present some highlights from our findings. For more detailed findings, please check out the paper. The agent and auto-responses were generally perceived useful by most of our participants. Some benefits that were brought up included reduced pressure and obligation to respond, as seen from this quote from P4. Further, our participants also highlighted certain situations where auto-responses were particularly useful for them. For instance, P7 brought up texting while at stoplights, which was less frequent for them when an auto-response was sent out. In terms of what participants considered as good auto-responses, P10 mentioned that the information shared by the response had to be convincing. Multiple participants felt that sharing ambient noise did not attribute as a convincing reason, as shown by the following quote from P8. On the other hand, most participants liked the auto-response which shared phone usage. P9 explained that sharing phone usage does not give out too much information about them while still signaling unavailability. Similarly, most participants also found auto-responses sharing ringer mode useful. P9 felt that sharing ringer mode was useful since they are less likely to respond when their phone is on silent mode. P7 described why they preferred concise auto-responses as they did not leave room for speculations. Our participants also shared experiences with how some auto-responses led to speculations among their contacts. For instance, P11 brought up how sharing calendar event can raise questions about what the event was in follow-up conversations. There were also multiple instances of misinterpretation of the information shared through auto-responses. One of the most common misinterpretation was that of sharing that the participant was in a noisy environment. Multiple participants reported that the first impression of sharing noisy environment was that of being in a party or in a large gathering, as shown by the following quotes. Auto-responses and the information shared through them also led to participants sometimes altering the way they use their device and the agent. For instance, P13 recalled a situation where an auto-response was sent saying that they are listening to music and may not respond. They were not planning on responding immediately, but had to explain the auto-response to their contact. Finally, uncertainty and lack of understanding on how the agent worked also affected how it was used. As shown in the quotes from P8 and P11, not knowing if and how the agent will respond caused an increase in their device engagement, where they were constantly checking their phone to prevent an auto-response. On the other hand, P2 was frustrated at the lack of auto-responses that were not sent. The reason for that was they kept checking their phone to see if an auto-response was sent and were inadvertently attending to the messages, preventing agent action. Based on our findings, we have some design implications and areas to consider as future work. We observed that in a lot of ways, interaction with the agent was contextualized. For instance, P7 changed the auto-response delay based on the feedback from a contact, but switched it back to give themselves time to respond when they were available. Similarly, P8 stopped the application when they did not want the agent to learn about their behavior and act at a specific location. This highlights the need to consider additional context and awareness mechanisms where the agent can learn from these interactions while also teaching their users about their functions to enable more apt appropriations. In terms of future work, we are interested in understanding how people interact with the agent, how do they conceptualize these interactions, and how can we embed these into the agent's interface and design. For more details about this research, please check out the full paper along with additional resources on the study webpage. Thank you.